All right, so we're going to start out with solving some basic rational equations. Our first example, what is the solution to each rational equation? All right, so let's get in the habit of, because we're going to do this in an upcoming video. In the original problem, we can see that we have x plus 4 in the denominator. So if we think in terms of domain for this equation, we just know that x cannot equal a negative 4. So we're just going to keep that in mind. That'll come into play soon, but let's just be in that habit. So I'm going to rewrite the equation so I have a little bit more space. 1 over x plus 4 is equal to 2. Okay, so when you have an equation with fractions, we have done this before, our fraction trick. You can multiply the whole equation by your denominator. So that's essentially what we're doing here. We're going to multiply the whole equation by the denominator. Your equation has two terms, so we're going to multiply this term on the left right here by our denominator of x plus 4. We're going to multiply the 2 on the right, our other term, with x plus 4 as well. So every term across the equation is getting multiplied by x plus 4. So what happens on the left side is essentially that's an x plus 4 over 1. So those x plus 4's cancel, leaving us with 1 equals 2 times x plus 4. And we just got rid of our fraction. Now to solve from here, you guys know what to do. We would distribute that 2. So 1 equals 2x. 2 times 4 is positive 8. Let's go ahead and solve for x. We'll subtract 8 from both sides. We get a negative 7 is equal to 2x, and divide both sides by 2, and we get x equal to a negative 7 halves. Then we're going to do a check. We said that x couldn't be a negative 4. Did we get a negative 4 for our solution? We did not, so we're good with a negative 7 halves. We'll talk about what happens if you solve for x and you actually get one of those numbers we're excluding in the domain. So if we are looking for it the whole time, then it won't be a big deal when we have to do it. All right, so part B, same idea. I'm going to rewrite the equation, just want more space. 1 over x minus 3 equals 5. We have an equation with fractions, so let's get rid of our fractions by multiplying every term by the denominator. Our denominator is x minus 3, so we're going to multiply this term by x minus 3. We'll multiply that term by x minus 3. The x minus 3's, because this is an over 1, these will cancel, leaving you with 1 equals 5 times x minus 3, and then we solve this equation. So we're going to distribute the 5. 5 times x is 5x. 5 times a negative 3 is negative 15. Let's add 15 to both sides. Ooh, I forgot to talk about something in the beginning. We'll talk about it in the end. All right, 16 equals 5x. Divide both sides by 5, and x equals 16 fifths. So let's go back to the original equation. I started the lesson saying, we're going to do this every time, and then I didn't. All right, so in the original equation, we have an x in our denominator, so we need to think about our domain. We're going to make sure that x does not equal a positive 3, because then the equation would be undefined. That term would be undefined. So as we look at our answer, x equals 16 fifths, this is not a positive 3, so we're good with that solution. We found a true solution to the equation.